Good morning. Today we are covering section 1.7, solve absolute value equations and inequalities. We are going to be covering simple inequalities on the first two examples, and then on the back side we're actually going to be looking at the absolute value equations and inequalities. We have four different types of inequalities. We have less than and greater than, and the endpoint will be an open circle when we graph them. If it's less than or equal to or greater than or equal to, the endpoint will be a close point. Let's look at example number 1. On example number 1, we have negative 3x plus 14 is greater than 2. I'm going to divide it up in two different sections. I want to be able to isolate or leave the x by itself. I'm going to go ahead and move the 14 to the right, and when I move it, it's going to become a negative 14. I have a negative 3x greater than 2 minus 14. I have a negative 3x is greater than negative 12. I need to leave the x by itself, so I'm going to be dividing by negative 3. Remember that when you divide by a negative number, or when you multiply by a negative number, the inequalities will flip. So we have x is less than 4. Negative divided by negative is going to be a positive. Now we also need to graph it. We're going to be making a number line, and this is going to be a quick graph. We know that this is 0, 1, 2, 3, 4. This is less than, so it's going to be an open circle. And we're looking for the numbers less than 4. The numbers less than 4 are to the left. Let's look at example B. It's going to divide it up in two sections. We are going to be moving the 4 to the right. We need to leave the x by itself. When I move it to the right, it's going to become a positive 4. I have negative 3x, negative 3 half x, less than or equal to negative 13 plus 4. It's going to simplify the right hand side. Negative 3 halves x, less than or equal to negative 9. We have a fraction. In order to be able to cancel the fraction, we're going to be multiplying both sides by the reciprocal, so this will be multiplied by 2 over 3 and negative 3 over 2. On the right hand side, negative 2 over 3. Negative and negative is a positive, and this will cancel each other out. So we just have x. Because we multiply by a negative number, we're going to flip the inequality. To multiply this, we're going to place it over 1. You can multiply and then simplify, or you can actually just simplify it out first. 9 and 3 divided by 3, so this becomes a 3. This becomes a 1. Negative and negative is going to be a positive. 3 times 2 will give me 6. And some of you guys might have done 9 times 2 will be 18. 1 times 3 is 3. Negative and negative is positive. And then when you simplify, 18 divided by 3 will give me a 6. It's basically the same concept. I'll make a quick graph. It's a number line. This is 0. I'm going to assume that 6 is over here. And let me move it a bit. This is going to be a closed circle because we have the greater than or equal to. And we're looking for all the numbers that are greater than or equal to 6. All the numbers that are greater than or equal to 6 are to the right. On example number 2, we're looking at compound inequalities when we have two simple inequalities joined by an AND or an OR. If you notice on the first one, they're both connected. That's going to be an AND. And on the right hand side, you guys will see the word OR in between. And that'll be the difference. AND will always be connected, OR will be separated, and with the word OR in between. To solve an AND, on example 2a. Let's go and place our lines. We want to be able to leave the x by itself. So we're going to move the 1 to the right. It's going to become a negative 1, but also to the left, it's also going to become a negative 1. So if we move it to the left, it's negative 1. On the right, negative 1. Basically, it's just moving it. On the left-hand side, negative 5 minus 1 is negative 6, less than x, which is less than 3. And we're done. When we graph it, we have 0 here. We're assuming that 3 is here. Negative 6 will be on the left-hand side. Both of them are open. Now, let's go ahead and graph it carefully. We have x is less than 3. All the numbers are less than 3 on the left. Now, when we are graphing the other side, we have to read it backwards. So this says x is greater than negative 6. All the numbers that are greater than negative 6 are to the right. On example B, we need to solve each of those inequalities separately. I'm going to move the 1 to the right, becomes a positive, becomes a negative. X is less than negative 3 minus 1. X is less than negative 4. I should have done my line. On the right hand side, I'm going to move my 4 to the right, becomes a negative 4. We have a negative 2x is less than negative 4. 0 minus, because it was a 0 before, and I just moved that 4 to the right, so it becomes a negative. I'm going to divide by negative 2. So I have x 2. Remember, when you divide by a negative number, you have to flip the inequality. And in between, there should be the word or. We're going to make a quick graph. We have 0, 2. We're assuming the negative 4 is on the left-hand side. This far. They both are open, so on the negative 4 is an open. We're looking for the numbers that are less than negative 4, which is to the left. We're looking for the numbers that are greater than 2, which are to the right. Notice that whenever it's an and, they'll be connected. All of the numbers between negative 6 and 3 are solutions. Whenever it's an or, they'll be in opposite sides. So they'll be to the right and to the left. And those all those are the solutions. All the numbers are less than negative 4, and all the numbers are greater than 2.